Namaste. Today we are going to design a flexible pavement. Flexible pavement is designed by calculating the how much equivalent standard axle load is going to bear by the given road section. The value for equivalent standard axle load N is given by N equals to 365 divided by R times 1 plus R whole to the power N minus 1 times ADF, where A is annual average daily traffic, D means lane distribution factor, and F is vehicle damage factor. Here we are going to design NH032 Hetauda West road section. I have obtained some data from given website ssrn.avian.com. From this website, the average annual daily traffic for recent 10 years in given road section is calculated as 18,248 PCU, and the given road section annual traffic growth rate is 6%. Here we take CBR, effective CBR 6%. For 2 lane, here we are considering 4 lane road. For 4 lane road, lane distribution factor is 0.4, and design life for flexible pavement is normally taken as 30 years. As we are considering annual average daily traffic A in terms of PCU, so for each PCU, vehicle damage factor is always 1. If we consider different from passenger car units like truck, bus, or anything other vehicle, then the vehicle damage factor will be more or less than 1. But for passenger car unit, vehicle damage factor is 1. And putting these values in this equation, n equals to this equation, we get the equivalent standard axle load 210.63 into 10 to the power 6 ESA. That means 210 MSA, 210 million standard axle load, 210 million standard axle load. And for this axle load, standard axle load, and effective CBR 6%, we are going to obtain the thickness of pavement from Guidelines of Flexible Pavement Design 2021. From table 8, we get different thickness of different layer of road pavement as follow in this table. First of all, there is subgrade. We lace and we prepare subgrade soil to effective CBR 6%. After that, subbase course, granular subbase course of 300 mm is laid. Then after base course, water mix macadam 300 mm is laid. Then after 150 mm Binding course, dense bituminous macadam of 150 mm thick is applied. Then after wiring course of asphalt concrete of 85 mm is applied. And this data is obtained from guidelines of flexible pavement. By interpolating for 210 between 200 MSA and 250 MSA, we get these values. Thus we find the different thickness of different layer of flexible pavement in this way. Here the base layer, that is first of all soft grade of 300 mm is compacted and prepared with maintaining effective CBR up to 6%. Then after soft base course, granular soft base course of 300 mm is applied, prepared, and then base course of granular base course 300 mm is laid over soft base course, and binding course dense bituminous macadam of 150 mm is laid over base course, and surface course or wearing course of asphalt concrete with thickness 85 mm is applied on the top surface. Thus we design flexible pavement for given road section in this way. Okay, basically the base course and sub base course is usually constant 300 mm for most of roads. The surface course and binding course, these their thickness, the thickness of surface course and binding course can vary with the nature of road section. Okay, thank you.